So welcome to today's Tuesday talk. The topic of today is Transatlantic Perspectives on Battery Sustainability, comparing EU and US approaches to ESG in battery supply chains by Emily Burlinghaus. Emily is a German Chancellor Fellow and funded by the Alexander von Humboldt Foundation, and she has been with us since August last year. Prior to joining the IASS, Emily has worked, among others, at the American University of Iraq and the Atlantic Council in Washington, D.C., and remains a non-resident fellow at the Council's Global Energy Center. Her background is in Middle Eastern and Islamic studies, as well as energy and climate policies. Just before we start, please keep in mind that we are recording this session. And now, please, Emily, the digital floor is yours.
Hi, everyone, and thanks for joining today, and thanks, Achim, for the introduction. I will share my screen. So as Achim mentioned, I'm a fellow of the Alexander von Humboldt Foundation, and I will be based at the IASS over the course of the next year. My research focuses primarily on battery supply chains, and I'm focusing quite a bit on the new EU batteries regulation. And the title of my presentation for today is Transatlantic Perspectives on Battery Sustainability, Comparing EU and US Approaches to ESG in Battery Supply Chains. So just to give you an overview of what I'm going to be discussing today, I'll start with a background on batteries for the energy transition. So I'll give an overview of decarbonization goals in the US and EU, as well as growth in battery demand from electric vehicles and stationary storage, which are two markets that are expected to be the biggest growth areas for new battery technology. Then I'll go into sustainability considerations for battery production, focusing on two key factors: raw material demand and waste generation, as well as sustainability concerns in the supply chain, and I'll focus specifically on the case of electric vehicles. I'll go into a comparison between EU and US approaches to sustainable batteries, which includes an overview of the EU batteries regulation, an overview of US state and federal efforts to promote battery sustainability, and then a comparison between the two approaches. And then I will conclude with opportunities for further research. So I hope this presentation is useful to anyone who's interested in understanding policy frameworks in two of the biggest markets for batteries over the coming years. Obviously, the world's largest EV battery market, China, is not included in this presentation, but as my research progresses, I'm hoping to include more national frameworks for battery sustainability. So that will likely include China, as well as other countries that are active along battery supply chains. So broadly speaking, decarbonization goals require batteries. And the points that I list here aren't comprehensive, but they're basically to give a broad overview of some of the main goals, as well as those most relevant to the mobility and electric power sectors, which will need to experience the highest adoption rates of new battery technology in coming years. So in the United States, we have the Build Back Better agenda, and some of those goals include making half of all new car sales in the US electric by 2030, reduction of economy-wide carbon emissions by 50 to 52% of 2005 levels by 2030, and carbon-free electricity by 2035. In the EU, there's the Fit for 55 strategy, which aims to have 100% emissions reductions in new cars by 2035, and a reduction of economy-wide carbon emissions by at least 55% of 1990 levels by 2035. So slightly more ambitious than what we're seeing in the US. And then there's no specific mandate for carbon-free electricity in the EU, but there is the Renewable Energy Directive, which aims to have 32% renewable energy by 2030. All right, so broadly speaking, there are a lot of applications for batteries, consumer electronics, power tools, computing. But as you can see here, I've chosen two: electric vehicles and stationary storage for the grid, since those are two of the biggest growth areas for battery demand specific to the energy transition. And electric vehicles in particular are expected to account for approximately 90% of global battery demand between now and 2040. And one really important factor when evaluating the sustainability of batteries is the battery's chemistry. So I want to spend a little bit of time on this because the different metals and minerals that are used, as well as their ratios, have a significant impact on upstream and downstream sustainability. For example, when it comes to cleaning up dirty mining operations or incorporating recyclability by design principles into battery production. And many times when you fix a sustainability problem upstream, it has other sustainability or economic implications further downstream. So one of the best reports that I've found so far, tracking current and future trends for battery chemistries, specifically for electric vehicles and stationary battery storage, was actually conducted by the European Commission's Joint Research Center. And it was from 2018, but a lot of the trends still hold true today. And I don't have a graph, unfortunately, from that report, but I'll go through some of the conclusions because I think they're relevant. So when it comes to electric vehicles, globally between 2011 and 2017, the breakdown in lithium ion chemistry for electric vehicles was 53% nickel manganese cobalt, or NMC, 46% nickel manganese aluminum, NCA, and about 1% lithium iron phosphate, LFP, and other. In the near future, we can still expect NMC to dominate the market, but the ratios are going to be adjusted to be more sustainable. So if you're sort of not following what the importance of these battery chemistries are, basically, if you've been reading the news about electric vehicle developments or battery manufacturing, you'll see that a lot of manufacturers are trying to reduce the cobalt content in their batteries. And this is largely because of the sustainability concerns around cobalt mining, as well as human rights abuses that have been happening in places like the Democratic Republic of the Congo. So in some cases, electric vehicle companies like Tesla and Ford and Volkswagen have made commitments to use LFP in at least some of their vehicles. So this would be a complete transition away from using cobalt, at least for those specific vehicles. But even so, NMC is probably going to dominate the market out for the next 10 or 15 years, but the ratios of the metals are going to change. So instead of NMC 111, where there are equal amounts of nickel, manganese, and cobalt, the dominant chemistry will likely be NMC 811, so a much higher content of nickel to manganese and cobalt. So going back to the graph here, this is from a separate study by Wood Mackenzie, but it tracks with the JRC report. So again, most batteries on the market out to 2030 are going to be nickel-rich ternaries, and ternary just means that there's 3 metals, metal oxides used in the cathode. But with innovation happening in lithium iron phosphate, LFP, that market is also expected to grow. And there are a lot of other batteries that aren't on the market yet, like solid state, which are difficult to predict just because it's hard to tell how quickly innovation can happen and how quickly those can be deployed on the market. All right, moving over to stationary battery storage. Just to give you a sense of growth in the stationary battery storage market, according to the IEA, total installed battery storage capacity stood at approximately 17 gigawatts at the end of 2020. And in order to achieve a net zero emissions by 2050 scenario, approximately 600 gigawatts of battery storage needs to be installed by 2030. So basically there needs to be massive offtake in battery storage over the next 20, 30, 40 years. And one key trend that we're probably going to see is that markets are going to start differentiating between chemistries for electric vehicles and chemistries for stationary storage. And this is because stationary storage can afford to be bigger and less energy dense than electric vehicles, since they don't need to be put on board something that moves. And then as you can see on the slide here, over 90%, oh, sorry, you cannot see this on the slide. But for reference, approximately 90% of the market for stationary battery storage is lithium ion, and there are 3 dominant chemistries. So NMC is about 60%, LFP currently is about 15%. I think that statistic was from 2015, so it's increased a bit since then, and then also NCA. So again, in the future, LFP is expected to take up a larger market share, and NMC will decline, as you can see here. And this is largely due to the fact that LFP batteries are more sustainable, but have lower energy densities. Again, less of a problem for stationary storage than for EVs. And because they can be a little bigger and less energy dense, there are a lot more opportunities for innovation and new chemistries. So a lot of the batteries that are being developed right now, they're not even included on this graph, but there's a whole slew of them. For example, flow batteries, and then there's a bunch of subcategories under flow batteries. There's zinc batteries, sodium ion batteries, molten sodium, iron air, which is particularly exciting if you've heard of a startup called Form Energy, which basically converts rust to iron to charge and then converts iron back to rust to discharge. And I don't mean to just regurgitate a bunch of different types of battery chemistries and technologies here, but I'm doing that primarily for two reasons. One, because salt and air, as well as iron and zinc, are much cheaper and more widely available and accessible than things like lithium and cobalt. And then two, because innovation is happening so rapidly, it's difficult to predict what mineral needs are going to be in coming years. So this has a domino effect on waste and recoverability and recyclability, all of which need to be factored into policy frameworks in a way that's both economic and sustainable. And I'll come back to some of these points in later slides. So here, I just want to give a general sense of projections for raw material demand and waste as a result of battery production. So this first graph is from the International Energy Agency, and it shows growth in demand from battery-related materials from clean energy technologies in 2040 relative to 2020 levels. And there's two scenarios listed, the STEP scenario and the SDS scenario. The first, the stated policy scenario, is an indication of where the energy system is headed based on a sector by sector analysis of today's policies and policy announcements. And the SDS, or the sustainable development scenario, is what would be required to be in alignment with the Paris Agreement goals. As you can see, there are pretty significant differences in projections based on each scenario. And there are a lot of other factors that could impact raw material demand. So the IEA posits that lithium demand could be 13 times higher by 2040, for example, if vanadium redox flow batteries penetrate the market, as in the STEP scenario, or it could be 51 times higher if all solid state batteries commercialize in the SDS. And similar trends are seen with graphite, cobalt, nickel, and manganese because of uncertainty over how battery chemistries will evolve in coming years. And then on the waste side, according to Benchmark Mineral Intelligence, approximately 398,000 tons of batteries will need to be retired by 2025, which means they'll need to be reused, recycled, or become waste. So basically, that means within 3 years, there is going to be approximately 4 times the amount of batteries being retired than in 2018. And other estimates indicate that global recycling would need to grow by 25 times its current capacity in order to keep up with growing demand. So basically, a lot needs to happen in terms of policy and regulatory frameworks to accommodate the waste that would otherwise pile up. Okay, so broadly speaking, there are 4 main nodes of any supply chain: sourcing, making, delivering, and returning. And my main research focus for my project is on sourcing and returning, since A, those two things are closely interlinked, and B, they're the focus of some of the biggest conversations around sustainability. So these conversations involve topics like carbon intensity and environmental risks and human rights issues. And then I focus to a lesser extent on the battery manufacturing process, although as you can see, about half of a battery's emissions come from the electricity used in the manufacturing process. So this is important if battery manufacturers are required to declare their carbon footprint, which you'll see in later slides is relevant to the EU batteries regulation. The third point I have here is delivering. I list it because it's obviously a critical part of any supply chain, particularly ones that cross national borders multiple times, like batteries. But my research doesn't focus as much on this because it's a beast in itself, and then I'd have to get into decarbonizing aviation and transportation, and entire research projects could be devoted to that. But just as a quick note on this point, in addition to the carbon intensity, a key sustainability challenge with lithium-ion batteries is that they're often shipped in single-use or one-way packaging because they're classified as hazardous goods. So this is changing, but it still remains a key sustainability concern. All right, now we're getting more into the specific policy frameworks. And I apologize for the busy slide, but I wanted to make sure I had everything that was relevant on here. Just to give a general description of what the EU batteries regulation is, it's a first of its kind sustainable battery regulation that will replace an older battery directive from 2006 that the European Commission deemed too limited in its scope of battery technology and inadequate in its recoverability and recyclability of materials. And while the original directive included 3 battery categories, portable, automotive, and industrial, the updated regulation adds a separate designation specifically for electric vehicles. And just as a note on EU regulations, a directive is not legally binding. It allows member states more flexibility to incorporate goals into national laws, whereas a regulation is legally binding. It's a mandate for member states. So it's also, this EU batteries regulation is novel in that sense as well. Some key features include new targets for recyclability and recoverability of materials, new carbon footprint declarations, a battery passport that will digitally track key metrics across the battery life cycle, basically everything from sourcing and production to end of life and potential secondary applications. So the reason I have this matrix here with 13 points is because the batteries regulation is divided into 13 policy measures. And these policy measures are further divided into 4 policy options. So the first is business as usual, which would be just keeping the 2006 batteries directive. The second is a medium level ambition. Third is a high level of ambition. And fourth is a very high level of ambition. And the draft regulation lists preferred options out of all 4, which I have listed on this table. So I won't go through all the categories here because that would take a while, but I've highlighted some that are the focus of a lot of discussions and debates around sustainability and points of concern between industry and manufacturers and regulators. So that's recycling efficiencies and recovery of materials, carbon footprint for industrial and EV batteries, recycled content in industrial EV and automotive batteries, extended producer responsibility, provision of information, which is that battery passport that I mentioned earlier, and then supply chain due diligence for raw materials in industrial and EV batteries. So this would primarily address some of the sustainability and human rights issues at mining sites. And this is an overview of the US approach to sustainability, which I think objectively is less comprehensive than Europe's. And this is partly due to backsliding in the last administration, not only on clean energy, but obviously sustainable batteries. So there were a lot more state level initiatives than there were federal level. And it's also partly because the narrative in the US is stuck on China and national security. And this is something that the Biden administration is working with Congress on, but it still remains a key roadblock to even really proposing legislation. So unlike in the EU, efforts to promote battery sustainability have come in the form of strategic plans or recommendations, either from the White House or agencies like the Department of Energy or Environmental Protection Agency, and less so in the form of concrete legislative measures, with the exception of the infrastructure bill that was passed in November. But even so, that was more funding allocations and investments in R&D rather than mandates for something like a recycling program. So just an overview of some of the policies or the recommendations that have been developed. That first bullet point there, the 100-day supply chain review. This was developed in response to Biden's executive order on America's supply chains. So that was signed in February, and this supply chain review came out 6 months later in June. And it made a number of regulations, many of which were related to battery manufacturing, sustainable design, and recycling. For example, it recommended federal support for nickel and cobalt recovery from recycled sources, establishment of a national battery recycling strategy, targeted incentives for recycling, such as tax credits or rebates, and federal government support to encourage key industry sectors like consumer electronics to pursue recyclability by design concepts. But again, this was just a series of recommendations and potential strategies, not the development of a formal mandate. And then in addition to these efforts, there's also been funding allocated to R&D for new storage technology. So the Department of Energy has the Energy Earthshots initiative, and specifically the long duration storage shot. The goal of this is to bring down costs of long duration energy storage 90% by 2030. And this is relevant to sustainability just because long duration energy storage typically relies less on rare earth elements, rare earth metals, than current lithium ion technology does. And then there's a lot of R&D funding going to national labs like Sandia or Argonne to develop novel battery chemistries or advanced recycling efforts. So a big example of this, which was actually done during the last administration, was the establishment of the Recell Center to develop recycling technologies, and that was spun out of Argonne National Lab. Okay, and then there was the infrastructure bill, which I'm sure most of you heard about because it was in the news a lot last year. It allocated billions of dollars for grants related to battery materials processing, manufacturing, and recycling, as well as the DOE-sponsored lithium-ion battery recycling prize, which is a competition for startups and early-stage companies to develop novel recycling technologies. And then the last thing I have here on the federal level are due diligence efforts. And due diligence is primarily a concern with critical minerals used for batteries. So in terms of actual regulations that the US has governing due diligence, the Securities and Exchange Commission has the conflict minerals rule, which requires companies to report on their use and sourcing of tin, tantalum, tungsten, and gold, 3TG. And unfortunately, cobalt, which has been tied to human rights abuses in the DRC, has not been included on this list. And there have been a number of challenges to the law since it was passed in 2012. Given the Biden administration's focus on ESG, there's a chance that that rule could be updated, but so far there hasn't been any movement on it. And then ERGI is also listed here. That's the Energy Resource Governance Initiative, which is a diplomatic effort from the State Department to work with resource-rich countries to cultivate responsible mineral governance and facilitate financing for sustainable mining projects. A couple things you see lacking here on the federal side are an actual mandate for recycling and extended producer responsibility. So back in November, the Environmental Protection Agency proposed a national recycling strategy, which includes mention of EPR, which is good, but the original version did not specifically mention batteries. There was a long stakeholder engagement process, which included suggestions to expand the scope and include batteries alongside other energy technologies like solar panels and wind turbines. So that will likely be addressed in later stages, but so far hasn't happened. So most efforts so far have been led by states, and a number of states have passed EPR laws, as you can see in this map here. They're not all related to battery technology, but some states like California and New York have EPR requirements for rechargeable batteries. However, even with this state level leadership, there's only one jurisdiction in the US that has passed an all battery EPR mandate, meaning that producers of both single use and rechargeable batteries that are sold or offered for sale in DC must implement a battery collection program in coordination with a stewardship organization. And I also want to mention California here, since it's arguably the most progressive state in the country, not only when it comes to clean energy, but also in terms of planning for end-of-life management with lithium-ion batteries. So in 2018, the state established this lithium-ion car battery recycling advisory group, and that's aimed at ensuring that as close to 100% as possible of lithium-ion batteries are reused or recycled at end of life. But the recommendations from this group aren't expected until next month, after the group was established in 2018. So there's a pretty long lag there. And I think that's sort of an indication that the US really needs to pick up the pace on developing regulations around lithium-ion batteries. All right, I am almost done. I think this is the second to last slide. So just some comparisons between the EU and US approach. The terms principles-based and rules-based are often used to describe differences in legislative action between the EU and the US. Typically, in a principles-based regulatory environment, there's more room for interpretation. There aren't strict objectives, or actors can interpret the objectives as they see fit. And the rules are more abstract or universal. But they also require a more contextual knowledge on the part of the entity that's expected to comply. On the flip side, rules-based environments are stricter. The rules are more concrete and clearly defined by regulators, and they aim to achieve a particular objective. So there's less room for interpretation. I would argue that the Batteries Directive in 2006 was more aligned with principles-based, since it allowed member states to implement the legislation as they saw fit. However, with the legally binding nature of the new EU batteries regulation, that's definitely more rules-based. Legislative action is more often than not existing on a spectrum. So certain aspects of the new regulation that are more vague or open-ended, like a broadly worded strengthened obligation on removability or eventual carbon footprint classes, those are more principles-based. The US, on the other hand, is usually considered rules-based. And I think that's true with a lot of environmental regulations. You know, if you think of the big ones like the Clean Water Act or the Clean Air Act, you know, like federal statutes that set specific standards and have rigorous compliance requirements. But I mean, I think there's an argument to be made with sustainable batteries that there's not much of a regulatory environment in the US right now. But if you're looking at some of these new ESG disclosure requirements, particularly those that relate to mining of conflict minerals, that would be solidly in the principles-based category, because it's up to companies to conduct these audits in ways that they see fit, and very few of them use third-party agencies to verify. All this to say, there's not a clear-cut delineation between principles-based and rules-based and across these geographic contexts. Really quickly, I think there's a risk of overregulation in the EU and underregulation in the US. I have a whole list of complaints from battery manufacturers and industry groups who think that some of the disclosure requirements constitute regulatory overreach or put European battery manufacturers at a competitive disadvantage, although there has been a pretty positive reaction so far. And then in the US, manufacturers really just want more clarity on rules that they can expect in coming years. So the lack of solid policy and misalignment between state and federal regulations creates financial risk. Lastly, the EU is, of course, concerned by security and supply chain resilience, but they're more focused on using sustainability as a means to protect domestic manufacturers and also limit market entry for players who don't adhere to high sustainability standards. As I mentioned before, the US is still hung up on the China and national security argument. All right, so one of the reasons that I chose this as my research topic was because I felt that there was a gap in research on comprehensive policy frameworks for battery sustainability. So a lot of the existing research focuses on individual aspects of the battery supply chain, for example, sustainable mining practices, or battery recycling, or grid decarbonization to reduce the carbon intensity of manufacturing. So there's not a lot of research that focuses specifically or more holistically on all of these aspects together. And I think this holistic approach is important because of how complex and interconnected battery value chains are. Especially when it comes to developing coherent policy, there needs to be an understanding that addressing a sustainability concern at a mining site or further upstream, for example, by eliminating or by cleaning up mining processes at a cobalt mining site, might make it more complicated to pursue sustainability further downstream. So if a battery manufacturer or if car companies completely eliminate cobalt from their batteries, That's great in terms of mining, but it also may make recycling less profitable. So if there's a transition to LFP batteries, LFP recycling is much less valuable than NMC is. Likewise, given these complexities, by broadening a comparative analysis beyond just the US and EU, there are opportunities for lessons learned across different national contexts. So for example, China and Japan and Korea are all actively involved in battery manufacturing, and countries like Argentina and Chile and Australia are key players in lithium mining. And finally, while the US can learn from the EU approach to comprehensive battery legislation, there's a need for further alignment between policymakers, regulators, and innovators in these key areas that you see here. For example, technology and policy need to work together when it comes to addressing unsustainable mining practices. There's a need for greater oversight and due diligence to encourage supply chain transparency, and clean energy technologies need to be developed and deployed on a broader scale, especially those that can operate in remote locations like mining sites. There's also a need for more sustainable battery manufacturing, and this isn't only related to carbon intensity, but also to incorporating sustainability and recyclability into battery design. Lastly, there needs to be more sustainable transport and packaging used for transport, as well as end-of-life management. And this is particularly relevant to the US, which has not yet implemented federal standards for disposal and recycling of rechargeable batteries. And that is the end of my presentation. If you have questions, I look forward to answering them. Thank you.
Thank you very much, Emily, for the presentation. And I think we can just start right into it. If anyone has a question, so please just use the Zoom symbol, because we are too many people that I can't see everybody. So who would like to start or have a comment or so? I see Ilan, please.
Yeah, you can hear me better when I'm not muted. Thanks very much for a really interesting and very thorough overview of this. Well done. My question was somewhat with some chagrin is to ask, what do you think the implications? I mean, there's a issue in front of the US Supreme Court with regard to EPA and its purview in terms of pollution and CO2. Do you foresee that the changes in the US sort of legal structure and therefore on regulations would be potentially affected if that turns out to be, you know, if that law is reversed by the current very conservative Supreme Court?
So I do think that's a risk. I think that was a much bigger risk in the last administration, but we're obviously seeing similar cases now. I mean, I'm hoping with changes in the Supreme Court, that's going to be even less of an issue, but we'll see how long it takes to get someone confirmed if that's possible. I mean, I do think that's always a risk, especially like, as you said, with a more conservative Supreme Court. But Biden has shown his willingness to also use executive orders. I also think, you know, even though there have been some problem senators, I think there's still a willingness to negotiate. I don't think the policies that, you know, Biden initially had planned are really gonna get passed. I mean, some of the biggest ones. Yeah. I mean, the first thing that I'm thinking of that's not related to battery sustainability is the Clean Electricity Performance Program. And that was going to be sort of the hallmark of budget reconciliation. So I think that there is like a risk that that can't happen, but I also think with everything happening at the state level and California leading the way, I think there's an opportunity to move forward on some of these issues. And it's also just a market need too, like industry players and battery manufacturers and car companies are all going to want to have some regulatory certainty on what to do with lithium-ion batteries at end of life, because it's not just a sustainability tree hugger concern. It's there are legitimate safety concerns as well. So I don't know if that answered your question.
Yes,
Yeah.
that helps. Thanks.
Mm-hmm.
Thank you. Emily, perhaps you could stop sharing your screen so we can see us all easier.
Yes.
And in the meantime, Sonia, you have raised your hand, please.
Yeah, thanks, Emily, for a wonderful presentation. It was very, very interesting, and I learned a lot of new stuff. I'm wondering, since this is something I think about in my research about sort of transatlantic relations when it comes to this topic, do you feel like there's a maybe a particular format that sort of lends itself to discussion on these issues, where there could be more of a cooperative approach? Or I'm thinking maybe even G7, since this is kind of up right now, the German G7 presidency, or G20, or like a more of a bilateral format. I'm thinking, okay, I'm giving a lot of examples right now, just off the top of my head, sorry, but like this new German-American energy partnership, for instance. Is this something you're thinking about as well? Does it lend itself to this type of cooperation, or is it just going to always be that there's going to be two different approaches across the Atlantic?
No, I like to think that's not the case, that there's just two different approaches. And yeah, that was one thing that initially I had wanted to include in this presentation, opportunities for transatlantic cooperation. But I do think, as much as I've sort of hammered home the point that the narrative in the US is focused on China and national security, I think over the past, even before the Biden administration, I've seen an evolution from just, we have to onshore supply chains. We have to protect against any supply chain shocks in the event of a trade war with China. I think, there have been a lot of good people, even in the last administration, especially in this administration, who are saying, there's a need for cooperation with our partners in Europe. There's a need for cooperation with partners in Korea and Japan, especially when it comes to battery manufacturing. So I think there's a growing awareness that there are opportunities for, government to government partnerships and public-private partnerships that don't just involve, US companies operating in the United States. So yeah, I do think there are opportunities for that, but I wrote down some of the things that you mentioned as well, because I think yours were actually more specific than mine. I hope that helps a little bit.
Okay, thanks. Diana, please.
Yes, thanks a lot, Emily, for the presentation. Yeah, maybe sharing from my own research at the moment, we actually struggle a bit to identify what are really the raw material risks. I mean, given that we have also changes in batteries, right? That maybe different materials will be used. And then there are also all the discussions around the circular economy we are heading into, so that we kind of reuse a lot of materials. And while we are looking at this, I mean, I'm coming from this energy modeling background, and there you can see, right, we have a lot of predictions that we will have a lot of electric cars in the futures on our streets, and we try to grasp, right, is raw material really a risk there in the future if we go kind of really electric? But it's really hard. So it's I mean, there are different studies, but I mean, you often the life cycle assessment that our colleagues in Spain do is that they count with the materials we know that we use today, right? And just extrapolate it. This might be really wrong because our system will change, the materials you might use for batteries change. So I don't know if you thought already because this might have also then some implications, of course, on policies, right? Like what to intensify and how to bring up this whole discussion there. I just wanted to share that this is something I'm really concerned with, how to deal with this complexity underlying. Thanks.
Yeah, I do think it's really complex. And I mean, in some ways, it's encouraging to hear that the IEA is coming up with these wildly different scenarios for what raw material demands could be, but it's not just me who's very confused about it. But my sense too is that, there's not a concern with a lack of raw material availability. It's really an issue with processing. Like the processing capacity isn't scaling up as quickly as the raw material demand is. So even if there are, all these new sites that miners are finding, I mean, even in the US, like I think right now there's only one active lithium mining site, but like there's been a lot of press recently around the Salton Sea and the Imperial Valley in California. So there are I think there are a lot of opportunities for to develop raw material capacity, but at least from the US perspective, it's a processing issue because almost all the processing happens in China right now. And I mean, it's not just like a China trade war issue at this point. It's that it can't, processing cannot be controlled by one country in order to, because otherwise there are going to be supply chain shocks. And then one other thing that I wanted to mention that sort of goes to one of your points is that I think one of the big concerns with the battery regulation that manufacturers have are these really stringent recyclability targets. So I think there are going to be new streams to incorporate raw materials into new batteries. But part of the problem is if the recycling targets are so high, especially in the early days of the battery regulation being implemented, is it actually going to counteract some of the intended goals? Because then are you going to have to import recycled material if manufacturers aren't meeting these really stringent requirements? So yeah, I just think, and then like you said, with the development of new battery chemistries, I think it's just so hard to tell what regulators and policymakers should focus on in terms of improving the sustainability of these supply chains.
Okay, thanks. Any other questions or comments or additions you would like to make? That does not seem to be the case right now. So I would just out of interest, you've been focusing on the US and Europe, and you have been mentioning you would like to go to China, let's say, for processing, or another country case, if I understand it correctly. Would that be the big three in a way, or would there also be other places in the world where you think you could further elaborate or branch out and geographically branching out to include into your research? Or is it the rest of the world more or less suppliers of minerals or so?
So I think because the focus, so I had that slide that listed the 4 parts of the supply chain. I think because my focus is on sourcing and end of life, I'll focus more on countries that are, at least from the sourcing perspective, I would focus more on countries that are actively involved in mining of critical minerals. So Australia is the biggest miner of lithium. So I think it would be interesting to see to focus on some of the developments there. And there are actually some really cool startups and companies in Australia working on transparency for supply chains and identifying, particular faults in the supply chain. So they can use, something that I find interesting that I guess is a little outside the focus of this presentation is the use of digital ledger technology to identify points of unknown origin. So if there's a human rights abuse happening at a particular mine, there are technologies that can identify that, or if there's an excessively high carbon intensity of a battery manufacturing process, that can be identified. And I just went into that because I'm familiar with an Australian startup that's working on that. So I think Australia is really interesting, as well as countries in South America, in the lithium triangle, so Bolivia, Chile, and Argentina. And I think some of that also overlaps with the justice and sustainability work that's being done at IASS right now. So I'd like to focus on that. China is just so difficult. I don't have contacts in China. I don't speak the language. I know that China is considering, or I think they have an extended producer responsibility law, but I just don't know as much about enforcement of it. I think that's more the issue in China. So then in terms of, battery manufacturing, Korea and Japan are also interesting because you have companies like LG Chem or Panasonic that are involved in this.
Hey, thank you for the comprehensive answer. And I see that Andreas and Diana want to come in. Andreas, please.
Well, thank you for a great presentation, and I've seen that the project evolved tremendously and you know, in a very, very interesting way. So thanks very much for sharing that. I have to apologize already. I had essentially, I could not listen for 3 minutes because I had some kids stuff going on here. So maybe you've talked about this, but I was wondering whether you know, some of the EU level. So this is more of a geoeconomics question, right? So some of the EU level initiatives that we're seeing might make an impact, have an impact when it comes to sourcing lithium and other raw materials in a sustainable way. I'm just thinking about, for instance, the partnership the EU has now struck with Chile, and there are others in the making, where I understand there's a bit of a race going on. And I know they have written quite a few things into those agreements, but I was just wondering what your take is on this, and to what extent there might be certain standards that are set by these initiatives, and whether they indeed might become global standards, so that some of the issues you address might be mitigated. Thank you very much.
Yeah, I didn't know about this partnership between the EU and Chile, so I'll definitely look into it. That sounds interesting. Yeah, I do think, I mean, in terms of a race, do you mean like EU versus US developing these strategic partnerships?
At least the moment you talk to EU folks in Brussels, they start getting very concerned about the numbers you're presenting. You know, the demand increments by factors as much as high as factor 50 or something like that, and that inevitably raises some questions related to sourcing, supply security, but also obviously sustainability. That's essentially where I'm coming from.
Yeah, so I do think there are a lot of initiatives, especially when it comes to sustainable mining. There are a lot of groups that are either based at the national level or the EU level, or you know, multilateral organizations. I mean, there's the Global Battery Alliance, there's the International Responsible Mining Association, I think that's what it's called. There's ERGI in the US that I mentioned. But I think one of the issues, I think they're all great initiatives and a lot needs to be done in a very short period of time. But I also think there's a lack of alignment, and that's going to create confusion, which will probably slow things down as well. Like with the EU battery passport, which is supposed to track all these factors throughout the life cycle of the battery. I mean, there's a risk of there being overlap with the Global Battery Alliance's battery passport that they're developing as well. So I think, I don't know. I mean, I get the sense that it's just, I mean, there are these like organizations and frameworks that are being developed, but I also think it's just sort of a free for all. Like in the US, the like companies and the federal government are really concerned about like where are the minerals going to come from, and we have to develop domestic supply chains. So that's why there's this there's these mining sites in Nevada and being developed out in California and other places. So I just don't see a comprehensive framework for all of this happening in, you know, the time period that it needs to happen in order to achieve, you know, the Paris Agreement goals or net zero carbon emissions by 2050. But yeah, I mean, it's an area of an interesting area of research for sure.
Okay, thanks. And then Diana now, please, and then Sylvia. Diana?
Yeah, thanks. I think it will be short. I just actually had the same question as Andreas, but maybe following up. So the current legislations in the US, they don't contain like specific standards for mining, right? Like how like about social standards and this kind of things. Is this a topic, or is this somehow addressed, or do they refer to specific initiatives, or are they just like, you know, just focusing really on the material side, rather availability and circularity, instead of addressing the issue of sourcing? Just to be really clear. Thanks.
That's a good question. And that's something that I'd like to explore more. Historically, US mining companies have had higher environmental, social, and governance standards than, Chinese companies that are operating in, conflict zones. So I don't know specifically about US regulations for sustainable mining beyond the conflict minerals rule. And I really think that needs to be updated. There have been so many issues with the conflict minerals rule. I think in 2015, there was a court case where a company challenged the SEC and said it violated their free speech rights. And then they won that case. So, I think there's the conflict minerals rule needs to be updated. And I think it needs to include other minerals like cobalt. But I would say there are pretty strict ESG disclosure requirements in the US. Don't quote me on that. I think there's definitely room for improvement. So in terms of mining specifically, I'm not sure, but ESG disclosure, I think that's sort of what US mining companies would follow. But I will add one thing. I think, like I mentioned in my presentation, a lot of these companies just rely on their own reporting methods and they're not required to be audited by third parties. So I think, even if there are really high, even if these companies are self-reporting and saying their ESG standards are high, I think one thing that really needs to happen is a more standardized audit system. But yeah, that's a good question.
Okay, thanks. And now comes the next good question from Sylvia, please.
Hey, yeah, so I just wanted to say thanks for the presentation. Same, I also learned a lot. And there are a lot of things that I feel like I maybe need to look at your slides again to fully understand, because the scope of the technologies is really massive. I just had 2 comments, I guess, from my side. So the first is the difficulties of tracking supply and supply chains in a complex system. This is something that I was looking at a bit, and honestly, I would take this idea that companies are struggling to track things with a grain of salt. Oftentimes, companies do know where their products come from because they need to know how much they cost and if they need to change suppliers, if they can change suppliers. So I think I don't know, obviously it is, yeah, in complex products, the value chains have a lot of different steps and different actors, but in general, we do know where things come from. And so obviously sustainability requirements might put some pressure on companies, but in general, the ability to track things is not beyond the capabilities of companies. That's what they do all the time. And so to that end, I was wondering about the EU due diligence laws that there have been some discussions about lately, trying to eliminate some of these practices and try to make sure that suppliers are actually not participating in, really awful labor violations. So I was wondering if that's something that you've been thinking about in the battery context as well.
So in response to your first point about the difficulties or the lack of difficulty with tracking things happening in supply chains, I do think with auto companies, for example, it does get really complicated when there's thousands and thousands of suppliers, and those suppliers have sub-suppliers, and those sub-suppliers have sub-suppliers, and there's only so much that can be done. I do know that car companies, if a supplier for a raw material claims that they're adhering to high sustainability standards, sometimes the car company will go in and investigate, is that actually what's happening? But other times they just have to take these suppliers at their word because there's just not enough bandwidth to investigate every potential problem. So I do think that some companies truly don't know what's happening far down their supply chain. And that's what I think is really interesting about some of these startups that use this technology to track, down to tier 7 suppliers that wouldn't really, there wouldn't really be another way to do it. So I do think with like EVs and the materials required for EV batteries, that is a legitimate concern that they don't know where their materials are coming from or what their standards are at mining sites. With EU due diligence laws, beyond what's in the batteries regulation, I haven't delved into it enough to know exactly what's required. I get the impression just from complaints that people have about the regulation that it's too broad right now, that there are these due diligence requirements. You can't, be committing human rights abuses. You can't be committing environmental sustainability like violations. But I'm not sure how in depth or clear it is in the draft legislation. So I do think that's a problem. But I would be interested to know what like other due diligence laws are coming into effect and if they would apply to batteries. So sorry, I couldn't give you a better answer on that one.
Thanks. We are almost coming to a close, but we have enough time for a final question by Shikosi, please.
Yeah, thank you so much, Emily, for a very interesting presentation. And as I was listening, I was also I just asked one because of time. I kind of like noticed that the direction of the regulations and requirements were kind of somehow, correct me if I'm wrong, going away from the use of certain raw materials such as cobalt and lithium, of which you also rightly highlighted comes from countries chiefly like DRC, but also other countries like Zimbabwe, Namibia, and Mali in terms of lithium. And I'm like asking, do you find it a little bit problematic that, for instance, these minerals, for instance, are also the mainstay of these economies, for instance, to some extent. Do you think that this direction of thwarting or changing the raw materials to another material, that there is kind of a misdirection in that aspect, that there is no focus, for instance, on making the mining processes of these minerals more sustainable? For instance, in the countries where they're mined, and there is kind of like more focus on just making it more sustainable at the end of the value chain, and not necessarily kind of looking down the value chain to see, how does this actually affect the countries that, do have these minerals, and that these minerals are actually part of the mainstay of their economies. Thank you.
Yeah, I think that's an eternal debate, and it's not just related to these minerals. Like, it's the same thing over the past however many years with like oil-based economies in the Middle East. Like, if we transition away from oil, what's going to happen to those, communities that were dependent on, oil jobs? Yeah, I do think I'm not. So I think one point I would make is that in the next 30 years, that's not going to be an issue. I think the issue is we're going to continue mining cobalt. The cobalt is going to be more like the NMC batteries are going to be more for electric vehicles, because they're like, especially with people who want high range, like one of the biggest problems that people have with transitioning to electric vehicles right now is the range. And in order to get the range, you need to use NMC batteries. You can't make this transition to LFP in the next 10 years. So I think in terms of like, will those economies still exist? They definitely will. But I think like the relationships between mining companies and communities needs to be improved. And like the primary concerns there are going to be due diligence, is like the revenue from these mining operations going back to communities in like the right way? Are there community benefits agreements? So I think that, not to kick the can down the road, but I think like the chance that those economies for cobalt mining and lithium mining are going to totally disappear, that's not going to happen anytime soon.
Okay, thank you very much, Emily. We are coming to an end of today's Tuesday talk. Thank you again for the very comprehensive presentation. To all of you for the topics you have additionally raised. And I would just highlight the 2 links you have shared in the chat. So it's now a chance to click on them. And otherwise, there's nothing left to say from my end, just to say thanks again and have a nice day wherever you are currently. Bye.
Thanks so
to
much.
all of you.
Bye.
Thank you, Emily.
Thanks, Emily. Bye.